Hi there. Today we are talking about rational exponents. Remember what a rational number is. It's any number that can be written as A over B. So basically we're talking about fraction exponents. So really the good news here is we don't have to worry about absolute value. This is your base is A raised up to the 1 over n power. Notice that n is your index or root, and 1 is your power or exponent. Sorry, my hand is kind of cold. Okay, so we can write that as when you see a to the 1 over n, sometimes we can simplify it to a radical, but do note that our final answers need to be in the form that it was given. So if we change it to a radical, simplify it, then we have to change it back to a rational exponent, which is not the case most of the time. So anyway, let's give you an example here. So if I have 25 to the 1/2 power, this is saying the square root of 25 to the first power. Now that 1, and I'll come over here because that's basically what this is telling you, that 1 can be written outside or inside the radical. It doesn't matter. It does the same thing. So let me give you another example. How about 8 to the 2/3? All right, that's 3. 3 is your index, so we're looking at a cube root of 8, and you can put the 2 inside or outside. Since we're not using calculators, you're going to want to put it on the outside. Just because, you know, it's much easier to take the cube root of 8 than it is the cube root of 64. Actually, that's not a hard one, but the cube root of 64. So you can square the 8 if you want and then take the cube root, but my advice is to keep that 2 on the outside, do the cube root of 8, which is 2, and raise that to the second power, which is the cube root of 64, if you want to think of it that way. Okay, so that's all it's saying. Just also remember properties of exponents. If you have an exponent on the outside, please remind yourself that you are to multiply this fraction by this outside. We'll have a lot of simplifying problems, and you're going to have to use all those properties of exponents, and it doesn't matter if they're integer exponents or fraction exponents. So the denominator is your index. The numerator is your power or exponent. Okay, now these are just rewriting problems. You are not to simplify or evaluate. Just want you to get in the habit of writing these out. I lost my pen. I don't know where my pen is. Here we go. Sorry, my pen is not working very well. I'm all over the place. Okay, so I see here we have a square root of 4. There it is. And so 4 is your base. Your root is 2, so that's your denominator, and the power here is 1. So that's 4 to the 1/2 power. You will know your 1/2s, your 1/3s, your 1/4s pretty well. You know, we can still do some factor trees on some of these, but honestly, you're going to be just fine, and we're going to keep them pretty basic for you, okay? All right, so the 5th root of a negative 32. And again, we're not evaluating right now. 5 is your index. Your exponent is 1. Use parentheses because you're taking the 5th root of a negative 32, so use parentheses. Okay, here you're doing the 7th root of a negative 50, and you're squaring it. So that's negative 50 raised to the 1/7 squared. Okay, you don't have to show all of this work, but I just wanted to show you what you can do with that too. So that's 2/7. Okay, parentheses, because this was all underneath the radical, so you need to grab it with parentheses, okay? But you don't have to write it like this. I just assume you do 7 as your denominator, 2 as your numerator. Okay, here these are already in rational exponent form. We're going to change these to radical form. Do not simplify. 4 is your index. 4 is your base. 5 is your index. Negative 243 is your base. And the exponent is 1. You don't have to write 1 if you don't want to. This is the 4th root of 10 to the 3rd. And you can write 3 inside or out. It does not matter. Okay, so now we're going to do some simplifying. And some of these, like I said, you won't really need to change it to radical form, but I'm going to do that in this notes video though. Okay, so 4 to the 1/2 power, that is the same thing as the square root of 4, which is 2. Here we have 9 to the negative 1/2 power. Now, negative exponents brings us to a different property of exponents. And remember what you do with negative exponents, you need to drop the base to the bottom of a fraction. So this will be 1 over 9, and your exponent, becomes positive. That is 1 over the square root of 9, which is 1/3. Okay, because it's negative, you need to drop the 9 to the bottom of the fraction. Exponent becomes positive, then that means square root. Okay, cube root of 8 squared. Cube root of 8 is 2. 2 squared is 4. Okay, all right, again, here's another properties of exponents problem. Remember, when you have x to the n times x to the m, you're to add your exponents. You do not multiply these bases. I cannot stress that to you enough. So this is 7 to the 1/2 plus 1/2. So that's 7 to the first power. 1/2 plus 1/2 is 1. Okay, we have another negative exponent, so I'm going to drop that to the bottom, and I'm going to make that 4 over 25 to the 1/2 power. Then I'll do 1 over. Now that half is being applied. Actually, okay, I'll finish this and I'm going to go back and do it an easier way. That 1/2 is being applied to everything, so that's 4 to the 1/2, so that's the square root of 4 over the square root of 25. 1 over 2/5, which is 5/2. And I should have shown this a different way, sorry. When you have a fraction being raised to a negative exponent, remember all you do is flip the fraction and it becomes a positive 1/2. So I should have done that way. That's how I want you guys to do that. If you have a fraction, it has nothing to do with this being a half. If you have a fraction being raised to a negative exponent, flip this fraction. Don't flip the exponent, flip the base. And then that's the square root of 25 over the square root of 4 over the square root of 4. Okay, here be careful with that negative 5/6. You do not, the negative 5/6 is on the 64. You do not have parentheses, do not add them. So this is -1, and then 1 over 64 to the 5/6. So -1 over the 6 root of 64 to the 5th power. Notice how we put the 5 on the outside because I don't know what 64 to the 5th is. But I do know that the 6th root of 64 is 2, and 2 to the 5th is 32. So this one is -1 over 32. All right, and similar problem. Pen is all wacky. All right, so we're going to drop this to the bottom and make that a positive 4/3. I'm going to change that to a radical, cube root of 27 to the 4th. And again, I don't want to do 27 times 4 and then take the cube root. I want to do the cube root of 27, which is 3. 3 to the 4th is 81. So this is -1 over 81. All right. Now, here we go. We have two different bases. We cannot multiply these two bases. We can't do it. What we can do is rewrite 125 as 5 to the 3rd. That kind of makes it look like a fraction, doesn't it? Sorry. So this is 5 to the 1/4 times 5 to the, what are you going to do to those exponents? When you're raising a power to a power, you multiply the exponents. 3 times a 4th is 3/4. Now you have the same bases. Don't multiply them. and then you add your exponents. 1/4 plus 3/4 is 4/4, which is 1. Okay. All we do here is add your exponents. This is weird. That should be a 4th. So, I mean, not weird. I mean, it is what it is, but let's reduce that fraction. 3/4 plus 1/4 is 1. X to the 3/2 over x to the 2/3. We are going to subtract those. Oops. X equals 3/2 minus 2/3. We need a common denominator, which is 6. 2 goes into 6 3 times. It's going to be 9. 3 goes into 6 twice. That'll be 4. So we get x equals, that equals x to the 5/6. Okay, so we have some simplifying involved, but we have always followed the rules of exponents. When we divide, we subtract. When we multiply, we add. When we raise a power to a power, we multiply. Okay, let's try some more. All right, cube root of 216. I wouldn't give you some, well, I would give you something that can't be simplified, but if you want to do a factor tree, you can. 2 times, what is that? 108. 2 times 54. 9 times 6, 3, 3, 3, 2. Here's a 2. Here's a 2. So we have 3 2s and 3 3s, which gives you 6. Okay. Cube root of a negative 27. Negative 3. Cube root of a negative 32. That is not a perfect cube root, so you need to make sure that you do a factor tree. So we have 2, 2, 2, 2, 2, and it's a cube root, so we circle 3 of them. So that'll be 2 cube roots of 4. All right, 256, the 4th root of 256. This is a perfect root, but in case you don't know what it is, 256 is 16 times 16. So that's 2, 2, 2, 2. This one is 2, 2, 2, 2. We're doing a 4th root, so 2 times 2 is 4. All right, now we have some fraction exponents here. That's the cube root of 125, which is 5. The 6th root of 64, which is 2. Cube root of negative 216. Well, we just did the cube root of a positive 216 up here, so this is going to be a negative 6. And the cube root of a negative 343. Notice the parentheses around that. Actually, that wouldn't make a difference on that one because it's an odd root. But anyway, the cube root of a negative 343. May not know this one, but this is a negative 7. And I could do a factor tree for that as well, but I'll just tell you it's a negative 7. All right, use the properties of exponents to evaluate each expression. You have a choice here of how you want to approach each of these problems. I personally like to get rid of the outside exponent first. If it has an outside exponent, outside of parentheses, I tend to get rid of that first, as opposed to dropping this whole thing down to the bottom of a fraction. So everything in here is being raised to the negative 3/4 power. So I use my properties of exponents and I say, well, that's going to be 16 to the negative 3/4 times y, and then I'm going to multiply these. So negative 8 times the negative 3 is 24. 24 over 4 is 6. So that guy is taken care of. Oh, 24 over 4. Yeah, sorry, 6. Now this is a negative exponent. No final answer should have negative exponents. So you're going to drop this down to the bottom, and that becomes a positive 3/4. And that's going to be 1 over the 4th root of 16 to the 3rd. 4th root of 16 is 2. 2 to the 3rd is 8. So that's 1 over 8. So our final answer is 1y to the 6, or just y to the 6, over 8. Okay, we just did one of these on the previous page. Bases stay the same. Add your exponents. 1/2 plus 3/2 is 4/2. So that's 3 squared, which is 9. Here we have 2 to the first times 2 to the 1/2. Do not multiply those. Add the exponents. Okay, so we have 1 plus 1/2 is 3/2. Here, add your exponents. 1/5 plus 2/5, 3/5. Multiply your exponents. Raising a power to a power, that's going to be 6 over 15. Reduce that fraction. 3 goes into that. 2/5. Everything here is being raised to the 1/2 power. And that's your final answer. Okay, nothing to do there. Okay, negative exponent here. We need to drop that x to the bottom. There's no need to change these to a radical because your final answer has to be in the same form as the given problem or expression. If you sat here and did 1 over the cube root or square root of x to the 5th, and you go 2 goes into 5 twice with 1 left over, how are you going to get that back into rational exponent form? Okay, very difficult and unnecessary. You're going to get 1 over x to the 5/2. So I'm not even going to discuss that anymore. All right, so x to the 7/5, subtract those guys. X to the 5/5, which is x to the first. Subtract. X to the negative 6 over 3, which is x to the negative 2. You cannot leave it like that. That's 1 over x squared. No negative exponents in your final answers, please. Okay. All right, subtract your exponents again. 3/4 minus 7/4. X to the negative 4/4. 1 over x, because that's x to the negative 1. All right, here everything's being raised to the 1/2 power. Now, oops, we'll go ahead and rewrite it. Now, nothing you can do with that, but you can simplify that. That's the square root of 49 over x to the 1/2. Okay, here everything is getting raised to the 2/3, so that's multiplying. 1/3 times 2/3 is 2/9. 1/4 times 2/3 is 2/12. You're going to reduce that. And then after you do that, you are going to subtract those. Common denominator is 18. It's going to be 4 and 3, so we get 2 to the 1/18. Final answer. Okay, all right, that's all there is to it. Solving comes next, and hope you guys are having a great day. Thanks for watching.